All right, so hopefully you just clicked right over from the last video and you're joining now for solutions of ionic compounds. And so again, how do we view solutions of ionic compounds? Well, in this picture here, we have an example of sodium chloride or table salt. If you were to put that in some water, it would dissolve rather quickly, and maybe you've done this, or I'm almost sure you've done this at some time, maybe to make some pasta or things like that. You've put some salt in the water and it dissolves very quickly. So what's happening here at a particulate level is all these guys here are water molecules, and this guy over here is sodium chloride, a hunk of sodium chloride that you've put in water. And what's happening here is the ions, okay, in the sodium chloride are attracted to the water molecules. So the water molecules are basically going to pluck off, for lack of a better word, or rip off chloride ions and sodium ions into solution. And that's what's being depicted here. So this is a sodium ion, and this is a chloride ion, okay? So the solution then, if we wanted to understand what's going on, the solution that results consists of water molecules, sodium ions, and chloride ions, okay? So again, we're gonna end up with water, sodium ions, and the chloride ions, okay? That's gonna be our ionic solution. All right, so here's another example. Here we have copper 2 chloride, which we saw in the last video, dissolving in water. So again, it has this really cool blue color. You put it in water and it completely dissolves. And what we're left with is chloride ions, okay? And these are copper 2 ions, okay? So again, you start out with a salt or a compound like this, and those ions are taken away and completely surrounded by these water molecules. And so you get these isolated ions floating around in solution. Okay, so again, this is what we end up with in solution. And for a lot of these things, you get really cool looking colors. All right, so when an ionic compound dissolves in water, right, again, a solution consists of water molecules and ions. And like I just said, the ions are independent or identified by separating the compound into its ions, okay? So again, we have copper 2 chloride, which was this guy right here, if you wrote down its chemical formula, and it broke apart into the ions, okay? Shown here. All right. So I believe next we have some example problems to do. We do, okay. So with that knowledge then, where we start with the compound and we break it apart into ions, we want to be able to write the formula of all species in solution for the following ionic compounds by writing their dissolving equations, okay? So what you're going to do, if you remember with chemical nomenclature, when we were looking at our tables of ions and kind of bringing those ions together to form the compounds, now what we want to do is the reverse. We basically want to undo the formula, bring it back to its ions, okay, and kind of reverse our thought process there. So it's not too tricky, but there's a few things to look out for that I'll kind of mention as we go through these examples. And it would be a good idea for you to have those ion charts in front of you for polyatomic ions and monatomic ions so that you can use them as a reference. I think that would be really helpful. Okay, so the last thing I'll say is that for all of these contain water in the solution, and it's water's implied, okay? So for me, you can include water in the chemical equation, or you can leave it out. I'm just going to leave it out in this video because I just want to be really clear on breaking apart these compounds and the ions. And like I said, the water molecules are implied. But if you write down water, I'm not going to take points off or anything like that. Like I said, it's implied. So if you leave it off, I'm assuming you know it's there. But if you write it down, all the better. Okay. So let's start here. All right, we're starting with sodium hydroxide. Okay, And if you look on your chart, okay, this is a sodium ion and a hydroxide ion. So when it breaks apart, you can think about it. I'm going to break it apart here into the cation and the anion. And I'm going to end up with sodium plus hydroxide. And remember, the charges of these ions doesn't matter. Don't forget their charges, okay? So the sodium ion has a 1+ charge. You can find that on the periodic table, or you could find that from your ion chart. And hydroxide has a 1- charge, okay? Again, from your chart. Okay, so let's go here. Let's break this compound apart. This is potassium sulfate. Okay, so we're gonna break it apart right there. And we're gonna get potassium and sulfate ion, okay? And I wrote it like this for now to point out something, a mistake that is common and that you might find yourself doing, but don't do it, okay? So remember, the sulfate ion, if you look on your chart, has a 2- charge, okay? So when you bring these things together, I should say too, before I do that, before I say what I was about to say, potassium ion has a 1+ charge, again, from the periodic table or from your chart on monotonic ions, or the video that we did on monotonic ions. You might be tempted, okay, this is wrong, so I'm gonna write it in another color. You might be tempted to bring this 2, okay, over there, okay? And again, this is wrong, so don't just pause the video right now and stop. The reason being is that 2 there came from the sulfate ion, if that makes sense. Because remember, for my formula unit, okay, my compounds here, when I bring them together, they need to be net neutral. So because the sulfate ion has a 2- charge, I needed 2 potassiums with a 1+ charge to balance out this chemical formula here, okay, the charge of it. So again, this is wrong because potassium doesn't exist as a diatomic element, right? We could look at our charts of diatomic elements and potassium is not one of them, okay? So the correct way to write this is we should balance it with a 2 coefficient in front. Again, I have 2 potassiums, each with a 1+ charge, okay, plus a sulfate anion with a 2- charge again, okay? So don't make the potassium diatomic, okay? It's not a diatomic element, all right? That 2 came again due to us having to balance the charge of the compound, okay? So I hope that makes sense. There's more examples of that as we go through here. Okay, so here we go. This is ammonium carbonate. So we're going to break it apart right there. Again, if you look at your chart of polyatomic ions, that's the ammonium right there. This is the carbonate anion. Carbonate has a 2- charge, and the ammonium has a 1+ charge, and I'm going to have 2 of them. Again, because that 2 goes out front. Okay, that 2 goes out front here, okay? And the ammonium, okay, was in parentheses. So right here, so I'll just write that here so you could see it. Okay, so it stays together. In other words, you don't need to break apart the hydrogens and the nitrogen. Remember, it is a polyatomic cation in this case, okay, a polyatomic ion. So it stays together. Okay, and we have 2 of them. Okay, so here we go. Magnesium sulfate. Going to break that apart. Okay, you're going to get magnesium plus sulfate. Okay, we already saw what sulfate was up above. And magnesium, if you look on the periodic table or your chart, it has a 2+ charge. Okay, so I need 1 magnesium ion, 1 sulfate ion to come together to form magnesium sulfate, which is what I had. And again, we're just undoing this. Okay, so why don't you pause the video and try to do the last one on your own? Calcium nitrate, and we'll do it together. Okay, so hopefully you did that fine. So we're going to break it apart right there. And what we're going to get is a calcium ion plus, and that 2, right, came from the calcium, or you could look at your table, or you could look at the periodic table, okay, to get the charge of a calcium ion, but there it is. And then we have the nitrate anion that has a -1 charge, and we have 2 of them, okay? And I'll just leave that in parentheses so you can see it, okay? So again, this 2 shown here comes out front, okay? You don't put the 2 there, wrong, okay? Don't do that. It's not the compound, okay? It's a nitrate anion, and we have 2 of them, and that coefficient goes in the front of the compound. All right. So that's it for that video. Again, just kind of reversing things that we already learned to break compounds apart into their ions. And then we're going to move on now into strong and weak acids. So hopefully you just click right over to that video, and I'll see you there.